In India, summer temperatures in certain areas can rise up to more than 50 degrees Celsius. Completely enclosed buildings behave like a greenhouse, letting heat in but not allowing it out, making the interior spaces of buildings uncomfortable. Air conditioning is then used extensively to bring down indoor temperatures, leading to an increase in energy consumption and related costs. Effective building orientation and facade shading can help buildings use minimum energy for heating, cooling, and lighting. Proper insulation in the facade further reduces energy consumption by making it difficult for heat to pass through inside the building. This helps keep the heat out in summer and traps it inside during winter. In Irad, insulation is coupled with simple fixed overhangs used to shade south-facing windows in the summer when sun angles are high. These shades have reduced solar glare and improved user comfort. Reflective materials are also used on the roof to reflect the sun and reduce the heat transmission into the building, helping in reducing the urban heat island effect. With measures such as these, a 15% reduction in annual cooling energy consumption has been recorded. Proper placement of windows can maximize natural ventilation and lighting. In a typical building, 25 to 40% of the energy consumed is used for artificial lighting. By allowing more natural light to penetrate, energy consumption is significantly decreased. Windows located high on the wall or on the roof will result in deeper light penetration and reduce excessive brightness. Vegetation outside the windows, curtains, and traditional jalis can be incorporated to reduce glare and filter the natural light, leading to optimal visual comfort. Both natural and artificial light can be used together. In Irad, this is implemented through a simple pulley mechanism.
With a building that's designed well, we can actually avoid the direct sun from penetrating into the building. And it's not maybe coming from one direction so that it's glaring, but it comes from a multitude of directions. The north, the south will be your best way and best orientation. So daylight is first, but you really have to understand of how to treat the sunlight in order to get great daylight within a space that people really enjoy.
Use of daylighting strategies can reduce 10 to 20% of the total building energy costs. In addition to savings, natural light creates a visually stimulating and productive environment for building occupants.
The efficiency of the people who come and work in this place have increased quite a bit. A couple of key factors is that a lot of green spaces are provided in the building. So wherever you're sitting, you should be able to see some greenery outside. So you're not compartmentalized. You're basically, it's an open environment that gives people to see greenery. And in addition to that, natural lighting comes in. And when we human beings operate much better in a natural lighting than in artificial lighting.
At Center for Science and Environment, large operable windows and open planted terraces allow maximum amount of natural light and ventilation. Lush gardens and trees in the complex create a cool microclimate, leading to improved productivity of occupants and health benefits in the long term. A solar chimney has also been incorporated at CSE. It brings in fresh air, which flows through openings inside the building. This improves ventilation and cools the temperatures inside by almost 5 degrees Celsius. At NIIT University, a displacement ventilation system coupled with earth-air tunnels was set up to filter and cool the air. This uses only 30% of the energy required as compared to a typical air conditioning system, ensuring a comfortable and dust-free environment.
no air conditioning, therefore no greenhouse gases that are a byproduct of air conditioning. And so we are ecologically responsible once again by not adopting air conditioning. We strongly believe that evaporative cooling is actually an alternative to air conditioning.
We have for every part of the building, we have about 45-50 meters long tunnels which are running 4 meters below the ground. And air is drawn through these tunnels, it is sucked through these tunnels, it cools down, and then it is brought into a machine which cools this further. And that air is supplied through ducts in the building, through every room. And you can see the ducts in the building, and we have a series of ducts outside the building which pull this air out by natural means.
Alternative sources of energy can then be set up in the already efficient buildings to further decrease dependence on the grid. Today, solar-generated electricity is used in the most isolated areas as well as in our cities. Photovoltaic systems can be used to capture solar-generated electricity and supply it to various systems.
With the photovoltaic array that is installed at Iran at the moment, which has a peak capacity of 35 kilowatts of supply, what we found is that this generates enough electricity for all daytime office functions to be run on solar energy, including ceiling fans and even the air handling unit fans you can run. The only thing that this is not able to take care of is the energy consumed by the air conditioning chiller. If I can do without this air conditioning technology, which is the real consumer of energy, actually I can be self-sufficient with solar energy in a 3 or 4 story buildings type of campus. All its needs will be met just by the energy falling on the roof.
Since we have installed the solar energy in this building, we have been saving up to 600,000 rupees per annum.
Biomass is another emerging technology for producing renewable energy on site.
The advantage of woody biomass or biodiesel is that it's a fuel, meaning it's called a firm source of energy. It's available, you can store it, and then you pyrolyze it or burn it or whatever else. It's definitely, in my mind, one of the major power sources for all rural areas of India, because at those densities, complete freedom from the grid can be potentially achieved.
At Terry Retreat, waste materials such as crop residue, straw, twigs and branches are used in the gasifier. The gasifier is able to provide for more than 70% of the electricity demand in the building. Any surplus energy generated is used to recharge the battery bank. The diesel-fed generator is used for less than 30% of the building's energy requirements. A control device, the power manager, uses the most efficient combination, deciding which is the better source of electricity at any given time. The complex saves 40 to 50% of energy costs over conventionally designed buildings at an additional investment of just 25%. The eco-commercial building, built by Biomaterial Science Private Limited, is a unique example of sustainable construction. The 2-story cube-shaped office building was designed by local experts using locally available materials and adapted effectively to suit the local subtropical climate.
Biomaterial Science Eco-Commercial Building Program showcases the importance of planning and material solutions to comply with the construction industry challenges. Our eco-commercial building concept is a great example of how we are putting our climate control strategies into practice. We designed this project with the motto, adapting a building to the climate is better than adapting the climate to a building. This concept can be adapted globally to any of the planet's various climate zones.
Based on the rigid polyurethane thermal insulation made of biomaterials and its own resources for generating renewable solar energy, the building can meet its entire energy needs itself for lighting, air conditioning, and equipment.
Taken over a year as a whole, our eco-commercial building generates 86 megawatts of clean renewable solar energy and consumes only 79 megawatts for its internal operations. The building generally consumes 50% less energy than the comparable buildings in this region.
This innovative eco-commercial building is carbon neutral. Energy consumption for cooling, ventilation and lighting is covered in full by renewable energy, all produced by the building's own photovoltaic system on its roof, which generates 100% of its electricity. These net zero energy projects show that approaches such as combining efficient insulation with renewable energies can help to dramatically reduce a building's energy consumption and therefore its carbon emissions.